Today we'll be solving inequalities using addition and subtraction. One new vocabulary is equivalent inequalities, which are inequalities that have the same solutions. One key concept in this section is the understanding the addition property of inequality and the subtraction property of inequality. The addition property of inequality says that adding the same number to each side of an inequality produces an equivalent inequality. And remember, equivalent inequalities have the same solution set. So you'll be getting the same answer when you produce an equivalent inequality. So here we started with a minus 2 is greater than negative 9. In order to solve for a, we can add 2 to each side. Adding the same number to each side keeps our inequality equivalent, and we get a has to be greater than negative 7. The solutions for a is greater than negative 7 are the same solutions we would get for a minus 2 is greater than negative 9. The subtraction property of inequality states that you can subtract the same number from each side and it's going to produce an equivalent inequality. So I have y plus 8 is less than or equal to 5. As long as I subtract 8 from each side, from both sides here, I'm going to get an equivalent inequality. So y is less than or equal to negative 3. So let's try a couple here on our own. So we're starting with x minus 6 is greater than or equal to negative 10. So to solve for x here, I can add 6 to both sides. As long as I add it to both sides, I'll have an equivalent inequality. So on this side, it cancels out and I'm left with x. I'm going to carry down my same inequality symbol, and negative 10 plus 6 leaves me with negative 4. Now if I'm asked to graph the solution set for this inequality, I can do so by creating a number line. And on my number line, the most important number for me to have is this negative 4, because that's what the x is being compared to. I'm going to stick that right in the middle of my number line. But I want to have a few other numbers labeled. I don't need a big number line, but I do need to label a little bit more than just the one number. So I'm going to do a few numbers that are closer to 0 here. Our numbers always go up as we go to the right on our number line. And a few smaller numbers going this direction. So my circle is going to go right there at negative 4. And since negative 4 can be a solution here, negative 4 is equal to the negative 4, I'm going to put a closed circle at negative 4. Now to decide which way I'm going to highlight on my number line, I have to try some of these different values in for x and see which one makes the inequality statement true. So if I plug in negative 3 is greater than or equal to negative 4. If I plug in negative 5 is not greater than or equal to negative 4. So I definitely want to highlight the numbers in this direction, numbers that are bigger than negative 4. There's the graph of my solution set. Let's try another. This time we have negative 8 is less than 1 4/10 plus m. So to get m by itself, I'm going to subtract 1 4/10 from each side. Here it cancels out, and I'm left with m. This inequality sign, I'm just going to carry it down here. And negative 8 minus 1 4/10 leaves me with negative 9 4/10. So when I go to graph this solution set, the most important number to have on my line is the negative 9 4/10. But I'll go a little bit larger than that. I'll go negative 9 3/10, negative 9 2/10. And a few a little smaller, negative 9 5/10, negative 9 6/10. My circle is going to go at negative 9 4/10. This time it's going to be an open circle because m cannot be equal to negative 9 4/10. So 9 4/10 here, the negative 9 4/10, it's not actually a solution for our inequality, so we keep our circle open. So we're going to test in some others here. So negative 9 and 4/10 is less than negative 9 and 5/10. That's not true. It's not less than that. So let's try this side. Negative 9 and 4/10 is less than negative 9 and 3/10. Well, that one is true. So I am going to highlight the values on this side of my inequality. These are the numbers that belong in my solution set. All right, let's try one word problem together. So we have an electrical circuit that overloads if there's 1,800 watts of electricity plugged in. We've plugged in a microwave that uses 1,100 watts of electricity. They want us to write and solve an inequality that represents how many watts we can add to the circuit without overloading it. So we already have 1,100 watts plugged in with the microwave. And we know we can add a bit more, so I'm going to call the watts that we can add W. But whatever we add to that 1,100, it's got to be less than 1,800 or the circuit is going to be overloaded. So there's my inequality. I can now subtract 1,100 from each side. And the wattage that I can still plug in has to be less than 700. So here they're asking us, which other appliances can we plug into the same circuit as the microwave? Well, anything that's less than 700. So we could plug in the clock radio with the microwave. We could plug in the blender with the microwave. It's less than 700. The hot plate is too much. This combined with the microwave would overload the circuit. The toaster is too much, would also overload the circuit with the microwave. But I could even plug in the microwave with the clock radio and the blender combined, because to combine their 350, it's still less than 700.